In this video, I want to talk with you about a solution I have built with agents using Mastra to solve a task we have at RunPod. So we have 43 workers, which are part of this RunPod workers organization. And each of these workers is like basically providing some kind of API for solving machine learning tasks or AI related tasks. For example, you could run Whisper for audio stuff, or you could generate images with Stable Diffusion, or you could run vLLM, do inference for an LLM. So like any kind of thing is basically what we can do with workers. And if you're wondering what the worker is and how it relates to what we are doing at RunPod, I will link to a talk I did where I'm explaining how serverless endpoints are working, and workers are a very important building block of serverless endpoints. So the task is that I need to maintain these 43 workers so that we can make sure that they're up to date, that they're working, and that people can just use them for their applications. And I didn't want to do this manually, so I thought about, okay, I have heard about Mastra, so I want to use agents to actually maintain and validate these repositories. So a set of agents should go here on this repositories and make sure that they are working, and if they're not working, that these are fixed. And for this, I created this architecture of multiple agents, and the main agent is called the janitor. And the janitor agent is an agent that is using an open source model called toolace, 2 llama 3.1 8 billion parameters, because I wanted to have something that is deployable on RunPod using vLLM, and something that is like very good in function calling. And there's this function calling leaderboard, which I took as inspiration, and I saw, okay, like there are like GPT-4 and this tool 70B model up here, but I wanted to have something that is like easier and smaller just to get started quickly. So I have chosen the toolace here, as it has also very good score compared to the number one on that list. And this model is based on llama 3.1, 8 billion parameters, and they actually have a data set to improve function calling. And they fine-tuned the llama 3.1 8 billion parameters to be very good at function calling. So this is the model I'm using for the janitor, which is the agent that is orchestrating everything and making sure to test everything. And the janitor itself has 4 different tools. The first one is the Git checkout tool. Me as the user, I want to just give like an repository to janitor, and then janitor should do everything on his own. So what I will do as a user, I will say, okay, please validate this repository. So in our test case, I'm having the Tim Petruski worker basic repository, and it can actually check it out using the Git checkout tool. And to give you an idea on how this repository looks like, this is like a very basic worker to get started. And the worker usually consists of a Docker file so that you can run your worker as a container, and also a handler function that gets executed inside of the Docker file, which is doing some kind of machine learning AI related task, and also readme requirements.txt to install some dependencies and some test input if you want to test this worker. Okay, so the janitor first knows I have to check it out. So I created a Git checkout tool. I could have used one of the predefined tools, but I wanted to learn how this is actually working. So I created this tool myself. And this is basically in the background, just executing Git commands on my computer directly. So I can do a Git checkout here. And also, like if the repository already exists, then it fetches the latest version of it. Then the next step that janitor should do is the Docker validation. And this step is important to make sure, okay, like we have this checked out repository, and now we want to see if we can actually build the Docker image. We have this build image step here. So this Docker validation tool is calling a workflow. And the workflow is an entity where you have steps that are like executed after each other. And the first step is build image. And this is then executing Docker commands on my computer to build the image. If everything is fine with building the image, then there's a next step called run container, which then tries to start the container that we just built. We just created the image, and now we want to run the container and see if this is working. Then there's a step called check logs, which is then requesting the logs from the running container. The last step is a report, making sure that the results of any of these steps is summarized. So if there's something broken, then we know, okay, these are the errors, and if everything is fine, then the report will just say, okay, everything's cool. The Docker validation passed. But going back to our example here, I introduced an error in the Docker file to make sure that the Docker validation is failing. So what we are doing here is we copy the README without .md into the root. And this is not working because the file is called readme.md. So this .md is missing when you take a look at the Docker file here. We are expecting that our agent is actually capable of fixing that error. When the Docker validation step is failing, we are going to the repair tool. And the repair tool is something else that the janitor has. And if there's a problem, then it can trigger the repair tool. And the repair tool itself will trigger another agent. And this is the dev agent. And the developer agent is running on Claude 3.5 Sonnet, because I couldn't find an open source model yet that is good at function calling and actually fixing code and finding the problems in the code. So this is what I'm still exploring. But if you have an idea what I should text, then please let me know and I make sure to update this project. Okay, so the developer has also a bunch of tools. List files, read file, write file, and search. When the developer gets the problem here from report from Docker validation, because the janitor gave this to the repair tool and the repair tool gives this information to the dev sees there is some problem in this kind of repository in these checked out files that I have locally. So I will list some files to see what is the structure of the repository. Then it can read some files, for example, reading the Docker file. And if the developer thinks there's a problem here, then it can actually also write to the file system. It also has a search tool, which is also handy if it cannot find something. So it can trigger some search and find files better if this is like a larger code base. Okay, so imagine that the developer found the problem, repaired it, and the tool responds, we found the problem, we fixed it. The janitor then knows, based on their system prompt, that the repair tool was done and it thinks it was repaired, that it should go back to the validation step and trigger the Docker validation tool, which will then do all of these steps as we seen before, building the image, running a container, checking the logs, and creating the report. And at this point in time, then, because it was repaired, the Docker validation is done. And when the Docker validation actually passes and we had like changes, janitor agent can use the pull request tool. And the pull request tool is triggering another agent, in this case, the pull request creator agent. And this agent is also using Claude 3.5 Sonnet, because instead of writing the GitHub tools myself, I was using the GitHub MCP server. And the GitHub MCP server comes with many, many tools. And to be sure that all of these tools are like executed in the correct order and also like not something is forgotten, because this is kind of complex, I needed a model that is like more capable. And so the toolace has not enough knowledge yet with this 8 billion parameters that it can handle the GitHub MCP server. I mean, it can call a few of these tools, but in the end, it was always failing to produce the pull request that I want to have on GitHub. But my hope is that I can switch this one out, because it's not coding related, it's just like intelligence related and following tools. So I'm also experimenting with the VAT tool 70b, as this has 70 billion parameters, is based on Llama 3.3 and should be better in function calling. Okay, so the pull request creator is using GitHub MCP server, which makes it possible so that it can just create a pull request for the repository that we have supplied in the first step on GitHub. And if this change is done, then we can actually see a pull request on our repository. Then let's take a look at Mastra, which I have running locally on my computer. You can see in the user interface, we have the agents, we have our tools, and we have the workflows. For the agents, we can take a look at the janitor, and what Mastra gives you is this kind of nice user interface, where you on the right side see the system prompt, where you also can see if janitor is actually validating something, then it should follow these kind of steps here: cloning a repository, finding the Docker file, validating the Docker image, checking container logs, and push changes to GitHub via pull request. And this is like the basic thing. And if the validation fails, it should also try to fix the problem. If the fixing is done, it should validate it again and do this 3 times, because we have this kind of loop here. And when the repository is repaired, then we create the pull request. And when we have multiple repositories, then it should do each of them after each other. And the model you can also see here, it's toolace. The provider is RunPod, because this API is running on RunPod, and also the various tools that this agent has. You can also take a look at the tools over here. If you go into tools and go on the janitor tools, You can also see the tools in some kind of description. And if you go on the pull request creator, you see that these are all the tools that are coming from the GitHub MCP server. And this is what I meant before, that there are so many tools here that it can easily be that the model itself has problems to actually select the correct tools. And this is why I couldn't use like the 8 billion parameters model for this kind of agent. And we also have the Docker validation flow, where you can see how the flow would look like building the image, running the image, taking a look at the logs and generating the report. But I actually prefer to not use this chat interface for testing. I have created a test here in my local project under tests called test janitor. And what is happening over here is that we are preparing the environment a bit. Then we're getting our agent from Mastra, providing a prompt. In this case, please validate the repository, which is the repository I have showed you before on GitHub. And then we can generate with our prompt, and this will then trigger everything else that we have seen before. So let's actually do this. npm run test janitor here, which is triggering our test file. And the first thing that is happening here is that the GitHub MCP server is started automatically by Mastra. And this is because in our pull request creator agent, we have GitHub MCP server here, creating this GitHub MCP server using the MCP configuration. And yeah, because Mastra is loading this agent, this MCP server is started, and then we can directly use this with GitHub MCP.get tools and then use the GitHub tools as part of our agent. The next thing we have is preparing the environment, making sure that the repository is deleted so we have a clean state. Then we have our prompt here, which is please validate the repository timpitruski/worker basic, the worker I have showed you before. Then janitor is using the get checkout tool for the repository that we have specified, and putting this into the local path at /repos. It will say, okay, the repository doesn't exist. We have to clone it. So clone this, and then we have this locally at the defined path. Then it will call the Docker validation tool on the specified path, which means like first step, actually trying to find the Docker file and then building the image. You can see it tries to find the file and the path where it checked out the repository. There's this Docker file that it found. Then it tries to build the Docker image based on the Docker file. And this is just executing Docker commands locally on my computer, making sure the platform is correct, which is needed for these worker to run on RunPod, also with a unique name for the image so that we can build the same kind of repository over and over. And then you can see output that you would usually get when building something with Docker locally, where it tries to get all the resources, the base image, and making sure this is working out. And then at some point it realizes, okay, like copy readme doesn't work because this file doesn't exist. So we have an error here, and the error says readme is not found, and the Docker build failed. Then in this kind of workflow, we are always checking via code if a step should be done or not, and because this first step is failing, we are not doing step 2 and step 3, like running the container and checking the logs, because the agent cannot build the image, so we don't need to do the other steps. We can directly jump to step 4, which is the report. And it says, okay, status is failed with the errors that we got. So like the last 8 lines of our output here, and we see, okay, like readme is not found. Then this result goes back to the janitor. Janitor says this is broken, so I can use my repair tool, which is then triggering the dev agent. And the dev agent is like actually checking out like what kind of files are in the directory that I have here. Then it reads the Docker file, and then it edits the Docker file. And when this is done, it can actually say like the copy instruction was broken, so I fixed it. Make sure that copy readme.md into readme.md. And it also lists all the files that were changed, because this is important, for example, the pull request agent, that it knows these are the files that were actually changed. Then the Docker validation tool gets triggered again by the janitor, because janitor saw this was fixed. My problem is now solved. Let's take a look at, I can build the Docker image now. So doing step 1 again, building the image building works. So it was successful. So we have our image locally. Then it can trigger step 2 to run the container, which is also working fine. And then from the started container, it tries to use a command to take a look at the logs. There's also nothing wrong here. So the validation report gets generated with the status of passed, because everything is fine. And because everything is fine now, the janitor can execute the pull request tool which is then triggering the pull request agent. And the agent, because it knows the Docker file was changed, it can read the Docker file and then create the pull request and make sure that this is then actually passed on to GitHub. And then we have some more output. So I'm just logging all of the messages, interactions that the janitor had. So just making sure that if something is broken, I can take a look at what is actually happening internally. So let's switch over to a repository and refresh here. We see that we have the pull request and it says fix the Docker file by correcting copy instruction for README. You can also take a look at the files that were changed. So it saw that we had this issue here, changed readme to readme.md and make sure that the copy command is actually working out. So that's super powerful and super nice. And let's just dive into like how this model is actually running. So on RunPod, I have created an vLLM worker that is using an H100 here. You could also use a less powerful GPU, maybe 48 gigabytes or 24 gigabytes even, because the model itself doesn't need so much VRAM. It actually needs, like 15 gigabytes to just have the model in VRAM. And then there's some stuff that goes for the PyTorch activation, and the non-torch memory takes also a bit of memory. So in the end, we are at maybe 16 gigabytes that are very much required, and then some space for the KV cache. Right now, it's very much because I have so much VRAM over, but like for my testing, I just wanted to have this powerful GPU. But I will make sure to test also other ones so that I can give like a better recommendation on how you can run this model. And the configuration itself, we have this model name here, which is the one from Hugging Face. Then for the context size, I defined 32,000 tokens here. And another important part is the enable auto tool choice. This needs to be true so that vLLM will actually allow our model to use tools. If this is not there, then it cannot use tools. And because this is in Llama 3.1, we should use the tool parser called Llama 3 JSON. And this default is working fine, but if you get longer context sizes, then this might fail. And this is why you see that I'm using a version of the vLLM worker with a fix I have applied. So hopefully at some point this problem in vLLM gets fixed, where multiple tool calls for Llama 3.1 and 3.2 are actually failing. I submitted my findings in this ticket here without this kind of fix that I have proposed here, which is of course not perfect. I just tried to find out like what could be wrong, and I saw that sometimes the generation prompt is missing, like the last prompt that is needed so that the model understands, okay, like this is the end of the conversation and now I need to stop generating more stuff. And if the fix is not in here, then vLLM will sometimes, if you have like a long chat history with many tool calls, just produce broken JSON, and then you cannot get the proper result. And this fix actually makes sure that this is not happening. But because of this is not part of vLLM yet, I created a custom image based on our worker that we are maintaining with the fix for Llama 3 JSON. If you want to use this model for your agent and to orchestrate the other agents on RunPod, you should use this. And I will make sure to update this in the description if there is a fix. But yeah, this is how you would actually run this on RunPod. And because vLLM does provide an openai-compatible API, we can create the OpenAI provider here, and then using the endpoint URL from RunPod here with our endpoint ID, and then everything else is then just like how you would use an OpenAI compatible API and use this model as you could use anything from OpenAI. And that's basically it. You can find Janitor as an open source project on GitHub with some information on how to get started, how to configure this, and how to run everything, and things that I will change here to this architecture, and trying out new open source models, especially this one here. And also I have tested it already, and there was like another error in vLLM that I need to take a look at how to fix this, as this is using a different parser. And this parser has also a problem producing proper JSON at some point in time. So this needs to be fixed. And yeah, that's it for today. Bye.